Hello everyone. Previously, I talked about the ethical concern of using human brains for the AI data processing. But after watching a video on DishBrain, I start to wonder, is it possible to use human brain? And more importantly, how could it differ from current AI methods? So I explored how is DishBrain different from human brain, and what could biosynthetic AI that learns like us do better than traditional and silicon-based AI. Let's start with this. Yes, the human brain can be trained in a way similar to DishBrain. The CL1 chip, for example, learned using spike timing dependent plasticity or STDP, the mechanism also used in our brains. CL1 gives rhythmic pattern as reward and chaotic noise as a punishment. This makes the rapid neural circuit plasticity to restructure its connection based on learning and experience and internal stimuli. But this is important. There is two key differences separate a CL1 chip from real brain. First, the CL1 chip uses electrical signal to learn. Our brain, however, rely primarily on neurotransmitter like dopamine or serotonin. A single neurotransmitter can stimulate the multiple brain areas simultaneously, allow more widespread learning. And second, and more crucially, CL1 chip respond to the reward and punishment. However, the brain is not just respond at reward and punishment. They will also respond to the third factor, meaninglessness and confusion. This is where biosynthetic AI can go far beyond today's silicon-based LLM, large language model. Like GPT, they learn by adjusting probabilities between words. For instance, cat is likely to be followed by meow rather than bark. If they just answer bark, they receive a correction signal, but when given nonsense, like triangle with four corners, they just still answers confidently. Why? Because there's no mechanism to recognize that the answer is meaningless. Humans, on the other hand, do recognize the meaninglessness through the neurotransmitter. Brain can deliver the third feedback signal called modulatory signal that represent confusion and irrelevance. When something just don't make sense, the brain stops reinforcing those neural pathways, and it allows to avoid learning the wrong thing and discard meaningless circuit and recognize when something feels off and correct it. In AI, this could mean fewer hallucinations, those moments when a model confidently gives incorrect or absurd answers. Moreover, LLMs cannot learn without reward or punishment. However, bio-AI learns like humans. They could recognize the confusion and exploring alternative strategies and try to make different patterns and improve dynamically. This third signal, confusion, enables recognize nonsense and reduce the hallucination and refine circuit using the avoidance circuits and eventually self-monitoring. Now, this ability doesn't stop at the better predictions. if an AI can identify confusion, evaluate its own self, and decided not to trust certain outputs, it's not far from self-awareness. And also, in fact, that's how emotions are emerged for as internal feedback, and the system judgment itself its own behavior. That's why companies today are trying to mimicking the spike-based third-factor learning using the spike neural network called SNNs. However, current GPUs aren't good at spike-based computation, and that's where the biosynthetic AI holds an edge. It operates natively spike-based computing, so if once the biosynthetic AI and neurotransmitter is integrated, it may surpass traditional AI both speed and learning depth. In the end, biosynthetic AI could be the something extraordinary. It's not just intelligent systems. It could be the self-aware system. In other words, a brain without a body. Thank you.